American city has at least one college, Worcester has 10. What's the ad trying to make you think?
That is a great city.
They want you to think, oh, Worcester must be a great city.
Well, what if it's not an American city? What
Well-
if it's a great city?
Well, you're in America. We're going to go with that. Because they're probably not going to put this billboard up in Great Britain. So we're going to go with that assumption, but you're right. We have to make sure we have the right assumption here. Every great American city is one. So is this enough evidence? Is this good enough? No.
If you have 10 apples.
No, it means 10 colleges. So is that a logical conclusion to, if every great American city has at least one college, Worcester has 10, therefore Worcester must be a great American city? What do you think, Joseph?
That's the great American city.
Well, again, how do we work with these conjectures? We kind of just, if the thing you're assuming is true, does this naturally follow? So we're going to assume that, let's assume this is true. So we're not going to question whether that's true or not. We're going to say, yes, it's true. Because they're telling us, so we're going to, okay, that's a fact. If somebody has 10 colleges, is it a great American city? Yes? What do you think?
There may be some great cities that aren't great, but they still have at least one or more colleges.
Absolutely. Does it work backwards here? So Worcester is a great city? Well, no. We only know that if you are a great city, you're going to have a college. But do we know if you have a college that you're a great city? Not necessarily. You could have a terrible college. But if you're a great one, you're going to have at least one. So it doesn't necessarily follow, but advertising loves that you're going to think it is. This is what advertising does. So they're not lying here. They didn't come out and say Worcester is a great American city. Well, that would be an opinion. They're trying to base it on fact, except they're using faulty logic. So these are conditional statements that we're going to be looking at. So statements that you can write in the form if-then are called conditional. Because if a condition is true, then a conclusion will follow. Now look at this little funny thing right here. This is notation for conditional statements. Sometimes there's a lot of English words to write. So we use this P, an arrow, and Q, and the arrow you read as the word implies. P implies Q. So for example, if an animal meows, then it is a cat. This is a conditional statement. For conditional statements, I look for if and then. This part here after the if is called our hypothesis. And if you're having an argument, you have to assume it's true. Because if it's not true, you don't bother. Right? So if there is no animal that meows, I don't care. But if an animal meows, my conclusion is it's a cat. And then we decide then truth or not. Is that true? Is that true if an animal meows as a cat? How can I tell if this is true or not?
People meow.
I know.
Sometimes.
Or people meow.
Yeah, it's a simplified.
So it's not necessarily true.
Like here's three people you each now.
So we assign truth values to conditional statements. This one I think is false. Now it's true a lot of the time, but if you can find at least one counterexample, we're saying, well, sometimes people meow. People meow. So if you can, maybe you would want to change this. If the only vocalization an animal has is a meow, then it is a cat. Then my counterexample goes away. So this is kind of how you beef up your conditional statements here. Now, how would I write this using this? So I'm going to call hypothesis, just give it a letter. I'm happy to give it P. I can call it any letter I want. I can call it A, G, whatever. And I'm going to call this one Q. I can write this as P implies Q as a kind of a shorthand notation for this long thing that's hard to write. P implies Q. Animal meows implies cat. Would be kind of a faster way of saying that. So let's look at some examples here. If the weather is nice, I'll wash the car. So is this a conditional statement?
No, no.
Well, what? No, it's not. How come?
Doesn't have
It doesn't have the then. Because the then isn't here, is it still a conditional statement? Now think about just English, how we talk. Do we always speak perfectly? Would we say this? Gee, the weather's nice, and I'm going to wash the car. Do we always put that then in there? Is it implied? It is. So conditional statements can take different forms. sometimes the then is missing. How would I write this as a notation? Let's say this is A, and this is B. How would you write this in notation? Yeah, what would I write?
A implies B.
A implies B. If 2 divides evenly into x, then x is a positive number. 2 divides it. So here's my, what is this part called? Hypothesis. And here is my conclusion. This one does have the word then, so it's easier to see it. And this one, this was my hypothesis, and this was my conclusion. And if we're going to call this hypothesis clause R, and we're going to call this conclusion S, I would write R implies S. Okay, so can we think of other conditional statements? One or two. Conditional statements, I'm waiting. Yes, ma'am.
Okay, so if it has green skin, then it comes from Mars.
Actually, a really good one. So what is the hypothesis? Amanda, what's the hypothesis of your conditional statement?
If it has green skin.
This part, just the it has green skin. Okay, that's what we're going to call our hypothesis. I'll call that under my 3. And then what's its conclusion?
It comes from Mars.
Good. And we'll call that Q. I can write it as P implies Q. What is the truth value of this conditional statement? Is it true or is it false? Now, can I prove it true necessarily? I don't know, but can I prove it false? Yeah. Lizards or a frog maybe, right? So it is a false thing, we can assign it. What about this one? If this one's a little hard to say truth value, maybe you will, maybe you won't. If it's me, it's probably going to be false. I'll find something else to do. And then, what about this? Yeah?
It's false.
False?
Yes. Because if it's a negative number that's also a even, then it won't, when you divide it by 2,
So what's a counterexample?
negative 2 divided by 2.
So negative 2, you're saying, well, what if x is negative 2? Then I don't get a positive number. So we're constantly kind of making those choices. Is it true? Is it false? Sometimes we can't prove it false. Doesn't necessarily mean it's true. Okay. So sometimes aren't already in the if-then form. So let's look at another example here. All birds have feathers. Is this a conditional statement? I heard no, I heard yes. Who says no? Why not?
Because it doesn't have a conclusion.
It's just a statement. You don't see an if as a premise in that conclusion. Okay. Somebody said yes. So who said yes? You say yes? How come?
Because if you say it like, if it's a verb, then it has feathers, it still has the same meaning.
So then you're saying if I can turn it into an if then it is. If it's a bird, then it has feathers. Now does it look like that if then statement that is our conditional? Absolutely. So you have to be careful. Yeah. Oh, that's a very good question there. That's a very good, she said, can we say if it has feathers, it's a bird? Is that the same meaning as all birds have feathers?
That's like saying
Oh, what
trees
an
are alive.
interesting
I am
statement.
alive, therefore I am a tree.
I'm alive, therefore I'm a tree, right? Because trees are alive. This is going back to if it's a great American city, it has one college, but if it has one college, doesn't mean it's a great American city. So we have to be careful about what is the hypothesis and what is the conclusion. I'm so glad you brought that up. Because what is the hypothesis here? It's talking about birds. So this has to be my hypothesis. And the conclusion is, if you are one of these things, you have feathers. That's your conclusion. So you got to be really careful. It's not always so easy. How about this one? Be careful with this guy. 2 angles are supplementary if they are a linear pair. You may not even know what all these words mean. Supplementary means they add up to 180. Linear pair means they're on the same line. Doesn't even matter. How would I write this as a conditional, traditional looking if-then statement? Now, what do you think?
if 2 angles are supplementary, then they are a linear pair.
So he says if 2 angles are supplementary, then they are linear pair. What do you think?
I got the other way.
You got the other way around. How come?
Because it's if they're a linear pair.
Here's my if. Now look at it. Now we speak English all kinds of crazy ways. And it's actually kind of backwards from the conditional statement. What's the hypothesis here? And what's the conclusion? If they are a linear pair, says this is the thing that kind of I'm assuming this is the hypothesis. If they are, then they're supplementary. So if I was to turn this into an if then, so if 2 angles are a linear pair, then they are supplementary. So you've got to be careful. We don't always speak, in pure if-then phrases when we're forming some kind of hypothesis or a conjecture. That makes sense. So you see now why we had to turn that one around. Questions on that? Yeah. Yeah, well, I look for that keyword if. I kind of zoned on that. If this thing happens, then that thing happens. However, if some things have something, then this is, you have to be this first to have that. So it's a lot of brain power involved here. Now really think about it. Let's see, forms of conditional statements. So if you have a conditional statement, if you have a P implies Q, there are other ways we can write them. So let's start with all birds have feathers. So I think we already talked about a way that we can make it look like a traditional if-then. So if the animal's a bird, it has feathers. Great. This is your conditional. All right. There's something called a converse. A converse is exactly what, I think I can't remember said, well, how about if it has feathers, it's a verb. A converse is when you switch the hypothesis and the conclusion. So if you have P implies Q, the converse is Q implies P. So let's look at this. Which one is P and which one is Q? I've got 2 clauses here. In my conditional statement, P implies Q, which one is P? Okay, no tricks. Just looking at this. Who's P, who's Q? And then which one's P?
And then it all is a verb.
Yeah, and which one is Q? Gotta be this one, right?
Yeah.
So if I want to write it as Q implies Q to get the converse, then what would I write? Yeah? If an animal has feathers, then it is a verb. So converse is swapping them. So that's another form of a conditional statement. How about this one, which is called an inverse? An inverse. An inverse is you take P implies Q and you negate both of these phrases here, both of these clauses. What does the word negate mean? Yeah. You're making it harder than it needs to be. So you hear the word negate, what word's kind of in there? Negative. So you're actually going to make them negative. So what is the inverse of P implies Q? Now look at the notation. We use this little squiggly line to mean not. We say not P implies not Q. Yeah. Exactly. If an animal is not a bird, then it does not have feathers. Not P implies not Q. So we found something that is not a bird. No, it doesn't have feathers.
Sometimes.
If a real animal is not a bird.
Well, sometimes you do have to specify them a little bit more.
If a non-extinct.
Some dinosaurs
real
had
animal.
feathers and they weren't birds, or were they?
No, they weren't.
I don't know. Don't they say dinosaurs are birds now? Like everybody has new theories about
No,
So
dinosaurs.
they say birds and boys are golf.
It's funny how the dinosaurs with feathers didn't fly.
All right.
It's funny how the pterodactyls.
Contrapositive. New word here. Listen inverse contra positive. What this is, it's like the converse and the inverse combined. So it's not Q implies not P. So how would I say my original statement, Joseph? So if an animal does not have feathers, then it is not a bird. Oops. Okay. Let's talk about truth now. I'm going to go with the assumption, and you may have counterexamples, but for the sake of argument, let's say this conditional is true. We're going to assume it's true. It may or may not be that maybe there are birds that have no feathers. I don't know about that, but let's assume it's true. Is the converse true? If an animal has feathers, then it is a bird.
Pegasus.
So she's saying Pegasus, we're going to say false? Because we have a counterexample? Pegasus, flying horse? All right. How about the inverse? Is this true or false? If an animal is not a bird, then it does not have feathers. They say, let's use Pegasus again. So this is false. How about the contrapositive? If an animal does not have feathers, then it is not a bird. If we're assuming if it's a bird, it has feathers, is it true or false that if it does not have feathers, then it's not a bird? What do you think? What do you think, Amanda?
Sometimes chickens or birds end up losing their feathers.
But they have them, right? In general, chickens have feathers, right? We're not going to look for that individual case. In general, right?
Every baby birds of some species are born without.
But the bird itself does have feathers, though, right? So, again, assuming this is true. Assuming this is true. So you can't just sit, now you're looking for counterexamples to this. I'm not looking for that. This is true. Let's say. Then is this true? Hmm?
Pegasus.
Yes, but the animal says it's not a bird, right? So is this true? And it doesn't have feathers. Pegasus is not a bird. Actually, Pegasus works for this, right? Yeah, just
No,
what
it
do you think?
doesn't, because it's stating on it.
Okay, wait, Joseph?
Griffins has birds. But there's part
No,
birds.
oh.
The chat, look,
All right, wait a second. One at a time here.
Your
Okay,
example
what do you-
needs to be.
Wait, Abigail, yeah. What? All right.
No, but it doesn't matter because
Butterflies
the
do not
example
have
needs
feathers,
has
right?
to not have feathers.
I'm looking at this. Butterflies. Butterflies don't have feathers and they're not birds. So butterflies actually work. Right? Now, Jack, what were you going to say?
The counterexample needs to be a bird that doesn't have feathers. That's the only word. that-
Right, and but over here it says, but birds have feathers. So I can't find a counterexample. So it has to be true. If this is true, this has to be true. Doesn't it? That's what I think you just proved that. Interesting. Pegasus works, right? Pegasus doesn't have feathers and it's not a bird, so it works. What?
Pegasus does have feathers.
Well then,
Yeah, but
then it doesn't work.
it's irrelevant.
Yes, sir.
But even if you found a bird that doesn't have feathers, that doesn't state that the bird does have, like, must have feathers. The contrapositive, it's just saying that if it doesn't have feathers, that's not a bird.
That's right. You're right, it's not saying it is a bird. An animal that doesn't have feathers is not a bird. It's the same as saying an animal is a bird if it has feathers, isn't it? You gotta wrap your head around it. You gotta really think about it. All right, let's look at some other examples here. All right, so identify the hypothesis and conclusion. So again, this is that tricky one. So which is the hypothesis again? This guy, that's your clue. And this was the conclusion. So let's write it out, right? This is the conditional now, in our traditional form, because it makes writing the other forms a lot easier. So, yeah, this is on the bottom of page 2, right? So if two angles are a linear pair, then they are supplementary. That's the conditional form of this statement up here, on conjecture. Okay. So what's the converse then of this conditional statement? The Q implies P? Yes, ma'am? Wake
If
up.
two angles are supplementary, then they are a linear pair.
Awesome. So with two angles, I'm going to use some abbreviation here because I don't like writing so much. This is how I write the angle symbol. So if two angles, you can write it if you want, are
I don't have
supplementary.
room to write the conditional.
Still working on the conditional?
Yeah, I don't have room for it.
Well, go to the next little section there. Do the best you can. You can also use other paper when you take notes if there's not enough there.
I have no idea how to use it. Do I just push to the edge? I have no idea. Help! Help, please! SOS!
Okay. I'll let you catch up with the writing. There's a lot of writing in these. If two angles are supplementary, then they are a linear pair because we've identified our P and we've identified our Q. Okay? Writing. Once you have that one, you can go ahead and try and figure out the inverse. Inverse is negating hypothesis and conclusion. A conclusion not P implies not Q. What do we think the inverse is? Jacob?
If two angles are not linear pairs, then they're not supplementary.
Two angles. Not a linear pair. Remember, go back into your conditional. And then if you finish writing that, go ahead and formulate the contrapositive. Not Q implies not P. Alrighty, so two angles are not supplementary. Then they are not a linear pair. Keep writing, but I'm finish these up. I find that most people are pretty good with the conditional, can remember not Q implies not P. Sometimes we confuse converse and inverse. What might be a way to remember the converse is they're both positive, you're just kind of switching them. And an inverse is you're not switching them, you're just making them negative. It's the thing that people tend to confuse. So what do you think? How can I remember that? What do you think, Debbie?
Inverse what they do, and you remember that they stay in place.
Okay, I like that. They stay in place. And it has that N, so maybe you remember what they're negative. Of course, that one has an N too. But they're in place negative. And then converse is the other one. You convert them, maybe? I don't know. You gotta find some way to remember it because it is one of those things that people forget a lot. You con them into switching places. How about that? Something that's gonna help you remember which one is this. Con into switching places. I'll go with that. Find one that works for you, because it is one of those things you tend to forget. Alrighty. So we got a bunch here on the other side here. You're gonna have to do the best you can here. I do some abbreviation here. All cats are mammals. What's the if then? Because it's very hard to kind of see, or maybe it is, what's your P and what's your Q. Find your P's and Q's, right? What's P and what's Q? Yeah. Right, so how am I going to write this as an if then? If an animal is a cat, then it is a mammal. You do what you need to do on your notes that you're going to remember what it is. On a test, I am going to ask you to write it all out because I'm not going to understand what it's code. There'll be plenty of room. You also have your own paper. You can use your own paper. You don't have to use these little boxes. Take out this paper right there. Converse is which one now? Is that the Now, how do I write converse in the notation form? This is P implies Q. What's this one? Q implies P. So if an animal is a mammal, then it is a cat. So what is this one? Is it true or false? You actually are Catholic.
Our dog has some.
That's pretty good statement. That's a projection. Alright, so, okay. And then the inverse is which one? This is when they are in place, but they're negative. So not P implies not Q. So if it's not cat, right? Then it's not a mammal. And then what's the contra? Contra is you switch them and negate them. Not Q implies not Q. Go back to the original. If it's not a mammal,
Catfish.
For some reason, I keep doing like writing a thing in the game that like data.
we're out of practice. I am too. Look at this. It's not. Stop following me, right? Okay, so she got it in there.
So
She
the
made it work.
OS, there's a RB
I did
17.
it.
I'm doing it 12.
And you'll see what kind of recommendation you get. You leave that day. All right, so easy, right? Baseball players are athletes. What would the if then be? What was that P implies Q? Yes.
If I'm not a baseball player,
If you are a baseball player, then you are an athlete. Money box. Converse. What is the notation for converse? You convert them on Q implies Q. If you want an athlete, then you are a baseball player. Okay, inverse, not P, implies not Q. We're in place, what we keep them. So if you're not a baseball player, then you're not an athlete. And then the contrapositive, not Q implies not P. And I do recommend putting these little notations down. It'll just help you really form it correctly. If you're not an athlete, then you're not a baseball player. Everybody stand Nathan yet? Yeah, me too. Yeah, why don't you skip the whole thing? Let's say why. You're in school now, we're writing again. If you're not an athlete, whoops. Then you are not a baseball player. Okay, so I want to go back to this truth value idea. So if we are always going to assume, for the sake of argument here, that our conditional is true, is our converse true? Let's see. If an animal is a mammal, then it's a cat. And I think Jack said, hey, that means I'm a cat. So is this true? I don't think it's a cat. How about our inverse? Listen, now you get the negation ones are harder. If an animal's not a cat, then it's not a mammal. Counter example to that? Us. See, fish is not a mammal, and it's not a cat. That
Or a
works.
catfish.
That's not a cat. Catfish is not a cat. True.
Well, yeah, cat.
All right, what about these? So if it's true that you're a baseball player, you're an athlete, okay, again, assume that's true, is the converse true? If you're an athlete, then you're a baseball player. False. If you're not a baseball player, then you're not an athlete. I mean, you could be a football player, right? You're still an athlete. How about the contrapositive? If you're not an athlete, then you're not a baseball player. Well, this is true. If you are a baseball player, then you're an athlete. So if you're not an athlete, can you be a baseball player? No. Yeah. That's a good question. What do you think? Right? Because it's just another way of saying the same thing. What about if you're converse, if it's true or false? What does that say about the inverse?
Those are the same numbers.
Same truth values. That's exactly the case. This one we're just going to talk through because I'm getting tired of writing too. So if all 180-degree angles are straight angles, what would be the if then? And that one I wrote right. Okay, what's a straight angle? This is a straight angle. So all 180-degree angles, how do you write this if then? Okay, so that's true. That's true. The converse, which is Q implies P, would be, you start with the straight angle. So if it's a straight angle, then it's 180 degrees. Is that true? If this is what a straight angle looks like, and if this is 180 degrees, which it is that true? If it's a straight angle, then it's 180 degrees. True. Haven't even written the inverse yet. Is it going to be true or false? True. If your converse is true, its inverse is true. Is your contrapositive going to be true or false? True. Because my original statement is true. So they can be true. I don't want you to think the converse and inverse are always false. They can be true. It can be one way or the other. Let's just state what this is. What is the inverse? If an angle is not 180 degrees, then it's not a straight angle. That is true. What would the contrapositive be? If it's not a straight angle, then it's not 180 degrees. That's also true. And we're going to be looking at more of these statements when we get into that. So questions about that? So I do have some ones for you to kind of try. Let's just do these two. I know there's a lot of writing, and then we'll see what you get. I'm going to start putting up answers, see how we did. But put in the truth values if you haven't thought about it. Assume the conditional itself is true. Given that's true, what can I say about converse, inverse, and contrapositive? Let's see how we did. It's okay if you didn't quite finish the second one. So let's see. Guitar players are musicians. So I said, you may have worded it slightly differently. If a person plays guitar, I used he, you said she, or he, she, that's fine. Then he is a musician. Again, I was saving letters. But then he is a musician. So if you get something like that. What would be the converse? Person is a musician, then plays guitar. Inverse, if a person doesn't play guitar, then he isn't a musician. Contrapositive, if a person isn't a musician, then he doesn't play guitar. Now for truth values, if the first one is true, I think you kind of got the idea that the contrapositive is also true, but does it make sense? So if a person plays guitar and he's a musician, if he's not a musician, could he possibly be playing guitar? Sometimes it's kind of hard to think about that. Now let's look at the converse. Is the converse true? If a person is a musician, then he plays guitar. Now, why is that false? Maybe you don't play at all. You may not have one. You may have never played one. So you can be a pianist and have never played guitar. If a person doesn't play guitar that he's a musician, same thing. That same counter example is going to work. All Great Danes are large. So if an animal is a Great Dane, then it's large. Converse says switch those two clauses. So Q implies P. If an animal is large, then it's a Great Dane. If an animal is not a Great Dane, then it's not large. That would be the inverse. And the contrapositive, an animal is not large, then it's not a Great Dane. So again, let's look at those truth values. If the conditional itself is true, is the converse true? If an animal is large, then it's a Great Dane. You got a horse. Or even like we could do dogs even though I heard wolfhound again if they're bigger than Great Dane. And that same counter example will work for your inverse. Contrapositive, it does work because Great Danes are large. If an animal is not large, it can't be a Great Dane. This one, because I skipped this one mostly because we may or may not know what these things are. You probably do, but we haven't really learned them yet. So we can move on. Unless there's questions. Are there questions? Now you guys are kind of brilliant at kind of noticing things. What did we inductively, and I said inductively, conclude about converse and inverse statements? Joseph? They're the same truth values, right? Yep, they're equal statements. And then what can we conclude about conditional and contrapositive? Inductively, we're just looking at some examples here. Same Boolean value, same truth value. So these are what we call equivalent statements. That word equivalent. If there's a place in your notes where I can equivalent, I think we're finding oh yeah. We're on page 3. It says they are blank statements. It's kind of near the bottom, that blank towards the bottom, in the middle-ish. We're going to right here. We're going to write the word equivalent because it means they have the same truth value. We'll write that word equivalent right in there. Yes, ma'am.
Is Boolean value a proper term?
Yep, Boolean value is correct. Yep, that means if something is true or false. A Boolean is usually just two possibilities. Okay, a biconditional. A biconditional statement is a statement where the original statement is true and its converse are true. So we've seen cases where a converse is false and where a converse is true. If your converse is true, that means all the statements are going to be true, right? That is a biconditional. Biconditional works both ways. Now we're going to use words when we describe biconditionals. We say if and only if. And I use this abbreviation up here. I say IFF. You're complaining about writing, so this is a shortcut. IFF, you see that means if and only if. So, notation. Here's a double-sided arrow. P implies Q, and Q implies P because the converse is always true. If you see this in notation, biconditional. So here's an example. An animal meows if and only if it is a cat. Now I was going with the assumption that the converse is true. If you have a cat, then it meows. And also if it's an animal, I was assuming an animal is a cat. If an animal meows if it's a cat, it's true, so is the converse. Other examples of biconditional statements that work the regular statement and the converse, both true. Any examples of that? Yes?
If a human is a lead singer of Maroon 5, then his name is Adam Levine.
And if you're Adam Levine, then you're the lead singer of Maroon 5? So how would we write that? Oh, there is that. But we're going to go with the Adam Levine. Or she's going to get mad at you, I think, right? There's only one Adam Levine. So if you're a singer, we're assuming truth. We're assuming truth here. If you are a singer for Maroon 5,
If you're a lead singer, there are multiple singers for Maroon 5, but also
for Maroon 5, if and only if you are Adam Levine. So this implies it works both ways. Okay? Which of these are biconditionals? So I'm looking at some of the previous ones. You can actually go over this one, but it would be biconditional because it's all true. Hard to read. This one was all true. It's biconditional. So, yeah?
What if the conditional is false?
Well, if it's conditional is false, I'm not going to bother. I don't bother. So, how do you turn this back into the two statements? Or how do you turn the statement you determine it is biconditional? How do you make it look like this? So So the first thing I think you said was if you are, or something like this, if you are a lead singer for Maroon 5,
Stop.
then you are Adam Levine. And then you decide that the converse is true. The way you turn it into an if and only if is you kind of remove this if and only if, or the if, you cross out the then, and you put if and only if here. That's how you can convert something you determine to be a biconditional into that biconditional statement. Yes?
If you're a bad actor, then you're melodramatic.
And if you are melodramatic, then you are a bad actor. So you are a bad actor if and only if you are melodramatic. That tells you it works both ways. I'm going to go. All right, last little thing here, compound logic. We're getting there. Almost done. So we have two new words here, conjunction and disjunction. I'm on the back on page 4. A conjunction is a compound logic statement using the word and. So compound means you're putting two phrases together, two clauses together. A disjunction is a compound logic statement using or. So, for example, if I have a clause that Joe eats fries, and I have another one that Maria drinks soda, right? These are two separate clauses. If you see this symbol, a P, and this looks like a little carrot, Q, this is P and Q. That's how you say it. P and Q mean Joe eats fries and Maria drinks soda. P and Q. If you have the upside down carrot, P or Q, that's how you say it. Joe eats fries or Maria drinks soda. And a conjunction is true if and only if both parts are true. So looking at a conjunction, that's and. So if Joe eats fries and it's true that Maria drinks soda, the whole thing is true. But if one or both are false, the whole thing is false. Yes.
What if it's and or?
Well, if it's a compound one that's just a little more complicated. So it's a conjunction and a disjunction all put together. That's a whole different story. We're just looking at and or. If a disjunction is false, if and only if both parts are false. So you can have true statement here. If this is true for that one, only one of them has to be true for the whole thing to be true. You gotta have to really think about these things. Because if one of these is false, the whole thing is false. If one of these is false but the other is true, the whole thing is true. And this is where you get into like logic a little bit more than we need to go into for this class. But if this is something interesting to you, you definitely want to take more logic in college. Now the thing to ask though is, how are you going to remember the carrot is the and the upside down one is the or? How are you going to remember that? First one's up and the second one's down. Well, and becomes before or and down. Oh, okay. Again, you got to find something that works. To me, it looks a little bit like an N. That N. So I remember that was the and. And then this is the other one. Maybe it looks a little like an R. It looks a little like an R if you want. But I just kind of remember it. That was the and, that was the or. You are going to have to remember which one is which.
Well,
Yep.
I honestly think the right side up here looks more like an A.
Well, then you want to get that out of this one, then you have to kind of get that out of your mind because that's the or. So maybe you can almost
No,
see
I
an
mean
R
the
there.
right side up here. I said.
This one?
No, the one on the top.
If it looks like an A, you're fantastic, but that's going to help you remember it. I'm just saying, you're going to find
Upside down.
Excuse me? So, just you find the way that works for you. This is what works for me. You find the way that works for you. Okay? Alrighty. Some you tries here on compound statements. So here I've got 3 different statements. We go to school on a holiday. Arbor Day is a holiday. We work on Arbor Day. Now I will say some of these things may not make logical sense, but I just want to see if you can write them in symbolic form. I'll do the first one. We work on Arbor Day. So which one is that? See? Or. So which one is or? We got this, we got this. Which one is and, which one is or? Yes? Oh, what's this one up here? What's the top one? And the this one, or. So, or, I'm gonna use this thing, or Arbor Day is a holiday. I've just converted into notation. That's what I want you to do here. For these two, for number 4, just to show you what I want here, I want you to convert it back to words. So what's A? We go to school on a holiday. Then what? What does this mean? And C, we work on Arbor Day. Yes?
Or number 2, we can put the school on.
Yes. So if it's not, this little thing means not. Let me give you a little warning. If you look this up, do some Google, there's other symbols that some people use. This is also a symbol for not. You may see different symbols for not, depending on who is, what they use. And look at this. Here's you're asking about ors and ands. You can combine them all. So this one, you're going to have, and then this one has a then. What's the symbol for then? Okay, so see if we can convert these into symbolic form here and words here.